In this section, in integration by parts, we're basically going to learn how to address some of those integrals that we haven't been able to address before. But to do that, we need to recall with derivatives what we called the product rule. And this integration by parts is basically going to use the product rule, or the undoing of the product rule, to help us solve some integrals that have products in them. So here we go. Let's recall it in a very basic form. If you have two functions, I'm going to call those functions u and v. I'm going to keep the very simple. Function u, function v. So if I have those two functions multiplied together, right, and I want to take their derivative, well, remember, u v plus u prime v, however you want to set it up. But as long as you multiply the derivative of one by the other and then do the opposite, you've got your product rule. So now I'm going to rewrite this a little bit differently. I'm going to call it d, just different notation for a second because it'll help, right? This is dv dx plus, I'm just going to put everything in terms of x, du dxv. All right, I didn't do anything but change the notation. So, undo it. So how do we undo it? We take the integral of both sides, dx. When I take the integral of this entire side, I'm going to separate it. So it's two integrals, dx, dx. Okay, well, taking the integral of a complete product or a complete derivative, which is what we have in this case, they basically cancel each other out. I think you'd agree, and we just kind of end up with uv again. But here's a little bit different because we're integrating and part of it is a derivative and part of it isn't. So if you just kind of cancel away your dx's, what you're left with is the integral of u times the derivative of u. And then in this the third term here, you cancel out your dx's. And now you are left with the integral of v times du. So this is kind of the backwards of the product rule, which as it's written won't help us. We need to rearrange it a little bit. And what we're going to use is this u dv as our main term. So I'm going to get u dv by itself. I'm going to move this to the other side, but I'm going to flip it on the opposite side. So I end up with integral of u dv equals uv minus, because I'm moving this over, the integral of v du. That's it. That is integration by parts right there. Know it, memorize it. That is essentially your formula. Yeah, this is one of those lessons where we just need to go through a whole bunch of examples in order to fully understand this formula and where it's coming from. Because how does this relate to a problem? Well, we're going to start with something pretty simple. So when I talk about you're finally going to get to integrate something you haven't been able to integrate yet, let's take a look at what I mean by that off to the side for a second. We all can integrate e to the x, right? Yeah, that's fine. That's e to the x plus c, one of the most basic integrals we know. In fact, the most simplest integral we know because the integral v to the x is e to the x. We also have been able to integrate x times something like e to the x squared. The reason we've been able to do that is because it followed this really nice u sub thing, right? If we let u equal x squared, we found, hey, du's in the problem, 2x dx. You know, we had to do a little manipulating, put the 2 in there, We have 2x dx, and it followed integration u sub so nice, and we ended up with the integral of e to the u du, which of course is e to the u plus c, which was e. You just had to substitute because it's an indefinite integral. Don't forget your half out front, sorry. And put your 2x back in. All right, so that was a nice u sub problem. No issues there. Here is where we would run into an issue. And this one I'm going to write over here. Integral of x e to the x dx. Seems like a simple integral to do. The problem is the second you try to do u sub, and you can't. There is no u sub. You know the integral of e to the x, you know the integral of x, but you cannot separate products of integrals. So you can't just say, hey, it's just, x squared over 2 times e to the x. No. Not a good thing. What we want to do with this one, and when you have a product that you cannot use u sub on, and you don't have a binomial where you can distribute it through, this is where you stop and you start to develop that plan. How am I going to approach this integral? This is where you need to stop and think about integration by parts. To do integration by parts, what we need to identify is a u and a dv. All right? So there's going to be, it's not until you do a bunch of examples that you really get the idea of what to make u and what to make dv. And it's okay because if you mess it up, you're going to get caught up in this problem that you're not going to be able to complete pretty quickly probably. And then you erase and start over and pick the other one for u and the other one for dv. All right. So here's kind of a general rule, which will work until we get to another problem, but it'll work for a little bit. General rule is let u be something that has the most simplest derivative, right? So in other words, if I just let u be x, we all know what du is. That's just a 1. That seems pretty simple. Let dv be something we can easily integrate, right? Well, ex is pretty easy to integrate. So let's try this. So when I say that, I am going to, for this one, choose this for u and my ex dx for v. So what does that mean? Well, I set up this little chart. You don't have to get fancy with the chart. All right. And first of all, what is in my actual function? Well, my actual function I have u is simply going to equal x, right? And I'm saying, sorry, it's dv. dv, let me move that over a little bit, a little longer. Oh, e to the x dx. So when you're identifying dv, you've got to use the dx part. All right, step 1. Step 2, notice, what do we need? We need a u and a v. We have a u, we don't have a v, we have a dv. We also need another v, and we need a du. So how do we get that? Now I do my derivative and my integral, right? I've got to get du dx. Well, du dx is simply the derivative of x, so that's just going to be, and du dx, would be over dx, but I'm going to move it to the other side. So that's 1 times dx. This one's a little more complicated. I'm going to pop it out of the box for a second. To get v, you need to integrate dv, right? So to get v, you got to integrate dv. In this case, you need to integrate e to the x dx. Well, all right, we can do that one in our head. That's just e to the x. All right. Now, once you have the pieces, I do this little arrow thing. Draw an arrow this way, and then draw an arrow that way. Okay, so the first arrow, oh, that's my u times v. My second arrow is what goes into the integral. All right, so now we have this equals u times v, which is x, e to the x, minus the integral of v times du. So e to the x, and notice you have your dx in there. It's 1 times dx, so that's just dx. If done correctly, so you'll know when you're stuck, because if you can't finish it at that point, you're stuck. But we can finish this, because that's just x dx. And what's the integral of e to the x? Minus e to the x. And don't forget your plus c, because we're doing an indefinite integral here. If it were a definite integral, no big deal. You would apply your limits to the first term, and then after you integrate, apply it to the second term, then just apply it to the whole thing at the end. Or you can just wait and just apply it to the whole thing at the end. You know, it doesn't really make that much of a difference. But that's it. That is the most simple integration by parts problem. So what do I expect to see? Yeah, I kind of expect to see, I don't need to see the whole green box, but I need to see what u equals, what dv equals, what the derivative of u is, and what the integral of dv is. That's going to help you immensely when you're doing this, keeping yourself organized. All right, so again, best thing for us to do is just go through quite a few examples. So let's get started. All right, next one I want to do, let's throw a cosine problem in there, or a trig function. So let's do the integral of x cosine x dx. Up to this point, you could not integrate that. If you try u sub, nothing's going to work. It's not going to work. So just like the last problem, we're going to keep this one pretty simple. Let that be your u, and that be your dv. And you'll start to see pretty quickly when to use integration by parts when you have these products, right? Identify, you know, if you have an x by itself, usually, not all the time though, and you'll see in another example real quick why not all the time, in fact, in the next example. Because here's the deal. Whatever you pick for dv has to be something you know how to integrate. That's important. I know how to integrate cosine x, I'm good. I can take the derivative of x and know it's something super simple. So this makes sense. Let's set up our quick little chart. So here, we'll just do I won't write out all the words out. Let u equal x, and then real quick, tell me what dv is. Make sure you include the dx part. All right. And then under that, you just calculate. I need du. It's actually, you're looking for du dx. I'm just going to move the dx to the other side. So that's 1 dx. And I need the integral, and you don't have to write this out, but I'm going to do it here. dv, or sorry, oh, I wrote d. V is the integral of cosine x dx. So v equals your sine x. Okay. All right, so it goes here to here, and then here to here. If you just do that, you don't have to think about it then. You don't have to memorize the formula. Makes it kind of easy. U times v, x cosine, sorry, x times sine x, minus integral. Don't forget to put the integral for the second part. Sine x dx. And then just finish it. Because remember, we picked something we can integrate. Now, You're going to see as we move along, sometimes you have to use the whole integration by parts thing again, but we'll get there. All right, so finish it off. That is x sine x minus the integral of sine is negative cosine x plus c, and then always simplify. And that's it. All right, so remember what I said. Picking. So far, every time we saw an x, we picked x as our u. Should you always pick x as your u? Well, let's take a look at another one. All right, now watch. All right, everything we've done so far, we said, hey, let u equal x, let du or dv, sorry, equals ln x dx, easy u du equals dx, and v equals the integral of ln x dx. Uh-oh. So here's the problem. Whatever you pick for dv must be an integral you know how to do. You don't know how to do that yet. We will try something in the next problem, but at this point, if you come across an integral you can't integrate, you can't let dv be that function because you can't integrate ln x. So, okay, like I said, if you ever get stuck, you just start and flip it. All right, so instead of letting u be x, let's let u be ln x and dv be x dx. Okay, and you can do that. Okay, just recall whatever value you set for dv, that's the one that gets the dx attached to it. Okay, well, what's du dx? Du dx is going to be, well, ln x is just derivative of ln x is 1 over x. So it's 1 over x dx. And the integral of x dx is x squared over 2. All right, so let's see how that works. Again, don't forget, we're going this way for the first part and that way for the second part, for our integral part. So our product is x squared over 2 times ln x. Okay. And then minus the integral of x squared over 2 times 1 over x dx. You can integrate that. Let's clean it up a little bit. I'm going to write this as 1/2 x squared ln x. Doesn't matter how you write it. And clean this up to make it x over 2. So we have our 1/2 x squared ln x minus 1/2. The integral of x is again x squared over 2 plus c. So you're pretty much there. I mean, you can simplify it more, of course. Let's do 1/4. Sometimes in the book you might see this. They might actually factor that out and give ln x minus 1/2 or something, you know, whatever. This is perfectly fine. I just want to remind you that your answers, if you're looking things up in the textbook or in your student solution manual, might be slightly different because they just simplified it or factored it more. Okay, so there is a case where it's better to let your x dx be the dv as opposed to letting x be equal to u. All right, so let's just keep going. Again, just doing lots of examples of this is just the best way to feel comfortable with it. All right, now, and the reason, let me go back to this one more second, is because we don't know how to integrate ln x. Guess what? We can actually even use integration by parts to learn how to integrate ln x. You're thinking, but how can I use integration by parts? I really don't have a product. Well, you kind of do have a product. You have a product because this can be your u, as we just saw in the last problem, and 1 dx can be your dv. Watch. U equals ln x, dv equals just dx. Well, we know u is 1 over x dx. V is the integral of dx, which is just going to be x. Do your little arrow thingy and then go this way. So uv is x ln x minus the integral of x times 1 over x dx. So that's going to be x ln x minus the integral of dx, which equals x ln x minus x. Another way you will see that written is x minus 1. You now know what the integral, either one, doesn't matter, of ln x is. And we used integration of parts to get there. So that is something that could come up. This is something that's really useful because if you don't remember it, you have to go ahead and go through the process of integrating ln x using your integration by parts. But yeah, as you can imagine, knowing the integral of ln x could come in handy. So there it is. All right. So what happens now if I have higher powers? Let's do x squared sine x dx. Okay. It's going to be an integration by parts. We're going to go ahead and let our u equal x squared, and then dv equals sine x dx. So I broke it up. Du, of course, is going to end up being 2x dx. And v is the integral of sine x dx, so that is negative cosine x. All right. Do your little arrows. Boom. And then this way. So uv is x squared times negative cosine x, so it's negative x squared cosine x. Minus the integral of negative cosine x 2x dx. I can bring that minus out and make that a plus, right? And just make it cosine. Actually, I'm going to put the, hold on. I want to put the 2x first. 2x cosine x dx. So here's the deal. Sometimes you have to apply integration by parts 2 times, right? Because this here, in order to solve that, I have a product again, and I need to do another integration by parts. Okay? That's it. You just got to do it again. So when I do it again, same idea. This time, u equals 2x dv equals cosine x dx. Du equals 2dx. So now you can see we're going to be done with this one. And v is the integral of cosine x dx, which is sine x. So clearly you can see when you're doing integration by parts, you've got to keep your head straight as to when are you taking a derivative, when are you taking an integral. So be careful with that. All right. So don't forget the first part, okay, which is our negative x squared. Don't lose it. I need uv, that's 2x, sine x, minus the integral of sine x. Yeah, because remember we did that, and now we need to do this. Minus the integral of 2 sine x dx. I can integrate that, copy the rest of it down again. Minus 2 negative cosine x, right? Because the integral of sine x is negative cosine x, so it becomes plus 2 cosine x plus c. Wow. That's it. Nothing you can do with that answer. I don't even think there's anything in there using trig properties. Hey, which we will do in 8.3. We'll get back to all those trig properties and remind you of those. Okay. Another little hint as to how to set up your u and v. Suppose you had x to a crazy exponent. I mean, I'll do 9. I don't know how crazy 9 is, but it's crazy enough. ln x dx. You can imagine, based on what we just did, if you let u be x to the 9th, you're literally going to have to use integration by parts a whole bunch of times. We don't want to do that. So hopefully you're starting to recognize now that, hey, whenever I have an ln x, let's just let u equal ln x. And then my dv becomes x to the 9th dx. Okay? Again, if you do it the other way, yeah, all sorts of crazy stuff will happen. So du 1 over x. V is, that's a 9. That doesn't even look like a 9. V equals x to the 10th over 10. Because here's what's nice about that. The only time you use V is, use it out here. So we have our, what do we have? We have 1/10 x to the 10 times ln x minus our integral. All right, so don't panic, but our integral becomes 1 over x times x to the 10th over 10 dx. But that's okay, because that's something we can actually integrate, right? So we end up with here. I'm going to just do this one off to the side for a second, right? I'm going to just do this. So what do we get? It's the integral of x 9 over 10 dx, which is x 10 over 10 times the 10 that was already there, right? So it actually is x to the 10th over 100. Yeah. So there we go. I'll put it back in the problem. So we have 1/10 x to the 10 ln x minus x to the 10 over 100 plus c. That's it. Which, you know, again, I can see a textbook taking the x to the 10 and 10 out of it and getting ln x minus 1/10 plus c. But either one would be considered correct. All right, so not too difficult. I'm going to show you one last little trick. I don't know how often this will come up, but it could come up. So let's try it. Integral e to the x sine x dx. It appears to be just normal integration by parts. How you want to do it, you know, we're just going to go ahead and let u equal e to the x and dv equals sine x dx. So real quick, du is e to the x dx. And v is the integral of sine x, so that's negative cosine x. Okay, so go ahead and integrate. Get those two, get those two. So that's going to give me e to the x, so negative e to the x cosine x plus the integral. Oh, that's plus because I'm jumping ahead here. It's minus the integral of a negative cosine, which makes it plus. Plus the integral of e to the x cosine x dx. Okay. Now, I think you will quickly realize kind of what's happening here, but let's go ahead and do it. Clearly, we have another integration by parts. So recall what our original function was, e to the x sine x. But we have another integration by parts, so we got to do it again. So part 2, integration by parts, number 2, equals e to the x, dv equals cosine x dx, du is e to the x dx, and v now is sine x. All right, let's put it back in. Copy what you already have. And then I have plus uv, which is e to the x sine x. Right? Minus the integral of e to the x sine x dx. And honestly, it's really not going to matter what you let u and v equal to. Do you see what's happening? We're going to end up in this repetitive process. Because what do we end up? What do we have to integrate again? Oh my gosh, we're back to integrating this. Okay? So here's the deal, and here's the trick. This, let me write it out. All right? Let me just write this whole thing out. E to the x sine x dx equals negative e to the x. All I'm doing is writing what we did. E to the x sine x minus the integral of e to the x sine x dx. All right, that's where we're at. I need more space. That is where we are. And yeah, I can just keep going forever. It just becomes this reiterative process. So here's an idea. Take this and move it to the other side. Isn't that going to give me 2 integral e to the x sine x dx equals negative e to the x cosine x plus e to the x sine x? And if I go ahead and just divide everything by 2, I get e to the x sine x dx equals, divide by 2, simply equals a half of negative e to the x cosine x plus e to the x sine x. And if you want, you can bring the e to the x out. And we're done. So we had to use a little algebra magic in that one. And then we can get our answer. And lastly, I just want to show you that, so why that one sinks in. I want to show you that by doing a definite integral really doesn't change the process at all. So let's go back to one that we actually did already. Let's do our ln x, because now you can integrate ln x. All right. We already did this problem, so I'm just going to jump kind of into the parts that we already did. So this ended up equaling x ln x, right? But because I'll show you. Here it was. Wait a minute. Oh, it was way up there. Yep. Remember, it was x ln x minus the integral of dx. Okay, that's where we're at. So x ln x minus the integral of dx. But here's the deal. Because we are going from 1 to 2, please make sure you put that in there and you keep it there. And you don't have to do it yet. I'll show you why. X ln x from 1 to 2, and this minus x from 1 to 2. You can actually combine it and just do it all at once. Okay, I just wanted to show you that. When you're doing, you can do them separately or just wait and bring them back together at the end and do the limits all at once. So then you end up with 2 ln 2 minus 2 minus, when you plug in a 1, you get 1 times ln of 1, but ln of 1 is 0, so that just goes to 0 minus 1. So it ends up being 2 ln 2 minus 1. Yeah, negative 2 plus 1. And that's it. So that's how you do it if you have a definite integral. The best thing to do with integration by parts is just practice a bunch of them. Practice the ones in MATLAB, practice the ones in the textbook. And so you get into the feel of what to make your U and what to make your DV. Okay? Thanks.